Hello and welcome back to another episode of Effective JaRu, the series where we will read effective Java and try to port these items here to idiomatic Rust if possible. So, item 29, the last item in chapter 5, which is all about generics. Consider type-safe heterogeneous containers. Wow. I must admit, I didn't fully understand that. And I might, maybe now, maybe I have to look at it again, maybe look at the code just to understand what it does. And, So let's read a bit. The most common use of generics is for collections, such as set and map, and single element containers, such as thread, local, and atomic reference. In all of these uses, it is the container that is parameterized. This limits you to a fixed number of type parameters per container. Normally, that is exactly what you want. A set has a single type parameter representing its element type. A map has two, representing its key and value types, and so forth. However, sometimes you need more flexibility. For example, a database row can have arbitrarily many columns, and it would be nice to be able to access all of them in a type-safe manner. Luckily, there is a way to achieve this effect. The idea is to parameterize the key instead of the container. Then present the parameterized key to the container to access or retrieve a value. So maybe the idea is to cast the value to the parameterized type that is pretty much anything, something like that. So with the jump to Java 1.5, I think the type of a class literal is no longer class but class T. For example, string class is of type class string. When a class literal is passed among methods to communicate both compile time and runtime type information, it is called a type token. All right. So this is kind of used to make this work. Let's see. We have a favorite thing. Favorite container. So we have a private map from a class of, that's interesting, of anything to object. So in Rust, I think you wouldn't have that. You have to say, how's it called? An unbound? No, that's wildcard type parameter. And wildcard type parameters you don't have in Rust at all, actually. You would always be specific and say that this thing must support some traits at least. Or maybe no trait at all, but that's how you do it. Maybe if you support no trait at all, this is kind of the equivalent here. I don't know. So a wildcard could be anything, right? And you map it to an object, which is kind of the lowest level of any reference type. That's what they all share. All right, initialize it, and you are fine. So put favorite, I think, is the fun part, where you have a class of a certain type, and that will be associated with an instance of that class, right? So that's interesting here. That's what you say. And then you are able to put it in there because you have a wildcard type. It can be anything, which is interesting. That does exist. Get favorite. You pass it a class and you get the value of the respective type. So it's basically you use the fact that the type itself, the class, is, has an object associated with it. So the class object is of type, right? Probably it inherits from type. So if you would say class or class instance of type, it would be true. That's what I would be thinking. That's kind of my Python knowledge applied, which makes total sense. It's nothing special. I would think that Java works the same. Okay, so what do we put? We put a string class, integer class, class, and we put it in there, and then we get the stuff. I think the good thing is here that you make no manual, that you don't have to do any manual casts. It's all working. And it is working because of the typecast, right? You get the type, and then you say, well, I want to cast this instance in, I mean, we get an object here, right? I want to cast this object into myself, and that's kind of the key thing here. We can build without issues, and we can also run it and get all the information. So that's what happens if you print a type. You get the full class name, which contains the package and the class name itself, or the type name. You could say, I don't know what the print annotation is. User of as subclass to safely cast to a bounded type token. Have I seen this somewhere? So that also needs... maybe that is using... let's see. Annotated element. So that's part of the reflection stuff. Is this in... Have I read this? I can't remember at all. 29 print annotation. So the favorite stuff, fine. Here it is. Yeah, maybe I didn't understand that at all. I kind of skipped through that. Maybe I didn't actually read it, but I'm not sure. Okay, so let's try to figure out what it does by looking at the code. So, Java print annotation, we want a class and an annotation. We need 2 arguments. Class name is this, annotation type name is that. And then, look at that, you can actually ask the runtime to give us a class for a name. So everything that has been registered is there, class for name. Let's have a look at Java class API or something. Here we go. Let's see what we have. That's very interesting. As subclass, cast this class object to represent a subclass of the class represented by the specified class object. Okay, so this basically, I actually don't know what that would do. Class, is this supposed to be funny? Cast this class object to represent a subclass. Of the class represented by the specified. Well, I don't know what that would do, but we can maybe check the code. So the casting is here, the for name. That's a static one. Returns the class object associated with the class or interface with the given string name. That's pretty awesome, I think. So yeah, it's like a plugin system. Nice. Can you also list these? Get annotation, blah blah blah. So yeah, that's part of the reflection stuff, I guess. You can ask a whole lot of information about the types registered at runtime. Nice. I mean, if you are into this reflection stuff, interestingly, reflection stuff I think is mainly for meta programming. If you want to do that, cool. If you don't want to do that, you won't miss it. And if you want to do meta programming, code generation is actually a valid means of doing that. So in Rust, code generation or compiler plugins or macros would be what you would use. Code generation personally is something I have made very good experiences with, but it's also something that you can use everywhere, right? No matter what the language can do, you can use that in C or anywhere else. And yeah, let's see what it does. So we have the class name and annotation name, then we get the class for the name, then we use get annotation. So is this static? Yeah. Annotated element. Okay, so we basically cast the class, which is implicit, so we downcast it to annotated element. Let's bring that back up. Does it mean this is an annotated element? No. Oh. It is actually, because it implements this interface. And then from there, we have here we have an element. Unbound type token. Okay. And we get then we get Then we get a class for the annotation type name. And then once we have both we say, well, do the casting and stuff. I have no idea what this would give us. Maybe, yeah, and if we can run it, but I don't think that it will do anything because we need class and annotation. I have no idea what that does. But yeah, I think it's kind of part of the reflection how you use generics to prevent explicit casting of stuff. So it's very interesting. Good that it works. Right now I can't wrap my head around that. But probably, others can. And if ever you need functionality like that, you might be able to actually get into this. So yeah, I think that's it. I can't really think of any Rust equivalent for this. No, I can't. Because Rust is not really reflective, and stuff like that you simply can't do at compile time, at runtime, no chance. Unless you implement it yourself, like do your own thing. But this would basically mean that you would have some sort of a trait that provides type information, and all that you would manually implement. So it's really just a fake, right? And there's reflection is something that is just not there in Rust. And so far, as I said, I haven't missed it. But I think that concludes this episode. I'm looking forward to chapter 6 with plenty of additional items. I think chapter 6, let's peek, is about enums and annotations. So, looking forward to doing that. Thanks for watching and have a great day.